Okay, so today we're talking about section 11.5, which is the volume of pyramids and cones. So yesterday we talked about the volumes of prisms and cylinders, and today we're just taking a little shift off to pyramids and cones. Pretty straightforward learning target again. So nice in chapter 11. All the learning targets are nice and simple. I can find the volume of a pyramid and a cone. Okay, so a quick entry task here is to find the lateral area, surface area, and volume of this prism. And I've shaded the area of the base here, right? Remember that in rectangular prisms, you could actually pick any side to be the base because they're all parallel and congruent, but I picked this side here so that we have a consistent lateral area. If you would please pause and take a couple of minutes just to kind of review for yourself what's lateral area, surface area, how do we find volume of a prism? Okay, if you haven't paused yet, I'm going to get started on just going through these real quick. Remember for the lateral area, we want to do the perimeter of the base times the height. So my height obviously is 16, and my perimeter would be 11 plus 5 plus 11 plus 5, which will be 32. So the perimeter times the height for the lateral area, so that's like the area around the sides of these white rectangles, would be 512 centimeters squared. And then for the surface area, we add on, remember, the lateral area plus two bases, right? So my base on top and then my base, which we can imagine is underneath kind of the prism here. So the area of this base would be 55 centimeters squared, 11 times 5. So I'm going to do lateral area, 512, plus 2 times 55, right? Two bases, and that equals 622 centimeters squared. Again, remember that if you picked a different base than me, I tried to kind of make it obvious with this shaded side here, but if you picked a different base, you might have a different lateral area, but you should end up with the same total surface area as me. And then for the volume, which I think the volume is so much simpler, the volume, all you have to do is find the area of the base, multiply times the height. So we already found that the area of the base was 55. We already knew that the height was 16, and that gets us the volume of 880 centimeters cubed. Okay, so I've got some formulas here for the volume of a pyramid. I'm going to post a couple of links in the description that kind of help visualize how pyramids and cones are related to the volume of prisms and cylinders. What you're going to see in those videos is that if you could sort of imagine, like if this was my base, right, and I actually formed a prism with this base, so there was another base up here, the volume of a pyramid is actually 1/3 of the volume of the prism. And again, if you need help kind of visualizing that, I'll post some videos that should help with that. But so what we say for the formula for this, and this is the long version, so just to kind of give you the words for it in English, the volume is the area of the base times the height of the pyramid divided by 3. And if you notice the area of the base times the height of the pyramid, that's actually the formula for the area of a prism, right? So we're actually like finding the area or the volume, I mean, of a prism and dividing it by 3. So a couple of other ways to write this. Remember that the formula for volume of a prism was base times height. So we're basically taking the prism, dividing it by 3. Another way to write this is saying 1/3 base times height. So you might hear me say this sometimes. I have a little formula sheet that I'll send out to you guys at some point soon that I believe it says base times height divided by 3. So this is what you'll probably see more often. But if you hear me say 1/3 base times height, it all means the same thing, right? We find the volume of the prism and it's 1/3 of that, or it's divided by 3. So then for the volume of a cone, again, it's the exact same thing, right? We want to find essentially the volume of the cylinder, and then it's also coincidentally 1/3. So again, I'll show some videos for you guys or link some videos in the description that can help you to visualize that if you need some help with it. But so for the volume, we're going to do base times height divided by 3. And then remember we said for a cylinder, because it has a circular base, you could also insert pi r squared there. For the area of a circle to just kind of help you remember. But essentially, it's still capital B, the base, right? It just happens to be a circle pi r squared. So pi r squared times the height divided by 3. All right, so let's put those formulas to action here. In example 1, we are going to find the volume of this pyramid. So if you'll notice, it's really nice here because we have this lovely triangle highlighted out for us, but we don't have the height yet. So we're going to have to find that height in just a minute. We know, though, that we have to find the area of the base for prisms and for pyramids alike. So I'm actually just going to start with the area of the base. Remember we said with the pyramids that we're going to be looking at is that they're going to be regular, right? Which means that all of the sides of the base are going to be the same. So if this length right here is 40, we are going to assume for this chapter that all of those sides in the pyramid are going to be congruent. So it's essentially a square, 40 by 40. That gives us the area of that base down there, 1,600 feet squared. So next step we have to do, we know that we want to do the area of the base times the height and then divide it by 3, but we clearly don't have that height there. So if you see they've highlighted out this triangle for us really conveniently, we need to use the Pythagorean theorem. They've given us, remember from our surface area, the slant height, which is the height of the triangle that kind of forms the outside of the pyramid. So we can use that slant height and part of this base here to find the total height. So before we can get started on the height or using the Pythagorean theorem, we have to know two sides of the triangle. So since this is a square and this height is just going halfway, right? It's just kind of splitting that 40 feet length in half. That means that this bottom part of my triangle is actually going to be 20 feet here, right? Because it just goes directly down and it splits 40 feet length in half. So now I can do a squared plus b squared equals c squared. I bet you thought this Pythagorean theorem would go away and stop bothering you. It never will. So a squared plus b squared equals c squared. We're going to go through and simplify. So h squared plus 400 equals 625. Subtract 400 on both sides. And then because it's squared, right, I'm going to take the square root on both sides. This gives me a value of h as being 15 feet. So it's super convenient, right? I can just use that in my formula now. By the way, if you were paying attention, you might have noticed that this is actually a 3, 4, 5 triangle multiplied by 5, right? 15, 20, and 25. 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25. So if you recognize that, you don't have to use the Pythagorean theorem, but as always, just maybe make a note in your homework when you're doing your work, just that you use the Pythagorean triple instead of the Pythagorean theorem. So now I have all of my information and I'm going to just plug it into my formula to find the volume. So the volume is going to be base times height divided by 3. The area of my base is 1,600 feet squared. The height is 15 feet. So when I multiply those together, I get 8,000 feet cubed. In example 2, we're again finding the volume, but this time it's of a cone instead of a pyramid. So it just has that circular base instead. So again, I'm always going to start by identifying my base and finding its area. So the area of my base here, since it's a circle, pi r squared. Very clearly here, it's shown that the radius is 1 centimeter. So pi times 1 squared. 1 squared is just 1, and 1 times pi is, again, just going to be pi. So I'm just going to leave the area of my base as pi centimeters squared, but if you like to have that 1 there, it's not going to hurt anything. Feel free to leave it. Then the height, this is convenient, we don't have to use Pythagorean theorem. The height is just 3 centimeters, right? From the base up to the vertex of that cone. And then the volume, it'll be base times height divided by 3. Our base is pi centimeters squared. Our height is 3 centimeters, and we're dividing that by 3. So when I simplify that, I get to pi centimeters squared. Sometimes people will ask me, like, how do you get from this piece right here, simplifying it down to pi? And I didn't really show that on the last example. What I like to do is I like to just ignore my centimeters for a minute and just think of it as pi times 3 divided by 3. And I could also simplify that to 3 pi, right? If I multiply 3 times pi, that's 3 pi. 3 pi divided by 3. Well, 3 divided by 3 is 1, so that just turns again into pi centimeters cubed. So the simple way to do it is PEMDAS, right? Just multiply those top numbers together and then divide by the bottom one. Multiply first and then divide. One last thing I wanted to point out before, I think I have 1 or 2 more examples for you, is that in your homework, this is actually a direct problem from the homework, so I guess maybe you could get a little head start on it now. I'm not going to show you how to do it. But sometimes you're going to have the height of a cone that is like tilted over like this. And interestingly, the height still counts as the height from the vertex down to this kind of the same plane as the base, right? So again, you're looking for that 90-degree angle from the vertex down to like the floor area of your cylinder. So if you see some of these kind of tilted cones in your homework, I think there are about 3 of them, just look for that perpendicular length and that will be your height. So here 3 meters would be the height, 2 meters would be the radius, and you just plug it in like we did over here. All right, last 2 examples here. It's kind of a 2-part example for example 3. We're going to find the height given 2 different kind of situations here. The first situation is a cone that has a volume, so they've already done the work for us and found the volume of 48 pi inches cubed and a radius of 4 inches. So what we're going to start with is filling in what we know. We know that the volume formula for a cone is base times height divided by 3. We did this a little bit in chapter 10 with area also. I know that my base, right, because they asked me for the base here, I know that my base would be 16 pi inches squared because I have a radius of 4 inches. So there's not a spot to plug in radius here, but I know that my base is 16 pi, so I can kind of fill it in with that from my 4-inch radius. And then obviously I know that my volume is 48 pi inches cubed. So if I rewrite this and fill in everything that I know my volume is 48 pi inches cubed. I know that my base area should be 16 pi inches squared. I don't know my height yet, and then I know just from the formula that I have to have that divided by 3 piece that's there. So now I have to kind of work backwards and get h by itself. So what I did here, kind of the invisible step that I didn't show, was that I multiplied both sides by 3, and that gets rid of the divided by 3 on this side. That gives me 144 pi over on the left side here, and then just 16 pi inches squared times h. So the next thing I need to do is divide both sides by 16 pi inches squared. That way it cancels out on this side, leaves me with just h, which is the goal. And then over here, an interesting thing happens. You see that there's a pi and a pi here. Well, pi divided by pi is 1, so those will just go away. And then if I have inches cubed divided by inches squared, that's like inches times inches times inches divided by inches times inches. So actually 2 inches cancel out on the top and the bottom. And that leaves me with actually just one single inch unit on the top there. And then 144 divided by 16 is 9. So that means that my final height number is going to be 9 inches. In our second situation, we have a pyramid with a rectangular base, sides 4 feet and 5 feet, and a volume of 160 feet cubed. And again, we are trying to find the height in both of these situations. So I actually did a little sketch here because it helps me to visualize it a little bit. It tells me that I have sides 4 and 5 feet. I don't know the height, and then the total volume is 160 feet cubed. So again, I'm going to start with what I know. My base area would be 20 feet, right? 4 feet times 5 feet. And my volume is 160 feet cubed. So if I know that my volume formula is base times height divided by 3, we're going to go through and plug in everything that we know. A piece that students often forget about is that we have to actually find the area of the base here and over here before we can start plugging stuff in here. So if my volume is 160 feet cubed and my area of my base is 20 feet squared, then again, I'm going to have to multiply both sides by 3 to kind of get rid of the 3 over here. So multiply by 3. I promise that's a multiplication sign. And then after that, 160 times 3. I just feel like I need to change that. Okay, use your imagination, everyone. That's a multiplication sign. So 3 times 160 gives me 480 feet cubed. And then over here, I still have 20 feet squared times h. So divide both sides by 20 feet squared, and we get 24 feet for the height of the pyramid. So in summary, one question for you to kind of think about and reflect on or write down in your journal: what are 2 similarities between a cone and a pyramid's volume? And then here's your assignment. And again, there are a couple of challenge problems. They're word problems, so they're not that much more challenging, but they do kind of force you to think a little bit. So try those out if you're wanting a challenge this week.